Hi, take a look at this code. Can you see the problem with it? What if I show you the inside of use weapon? How about this one? Can you see the problem with it? The first code snippet crashes, saying that we can't get the property name of a null value. This is because we set held weapon to null when it breaks. But there is no way to know that it can even be null in the first place. That is, not without documentation or digging through other parts of the code. So to circumvent that, we have to place these null checks all over the place. And if we forget any of them, well, best case scenario, it's not a problem. Worst case scenario, it goes unnoticed until it becomes the cause of major bugs laying waste hours of your life and unrecoverable sanity. In the second snippet, the issue is less obvious. The code that you see does work, but a bug reveals itself if we were to introduce, say, a typo here. Suddenly, the price of a banana doubles. Why? That's because the function findIndexedInArray returns -1 if the element wasn't found, which indexes the last element of the prices array. So, similar to the previous example, we would have to know that this function can return -1 upon failure, and remember to handle it every time. So in this video, I'll talk about this plugin that I created to address this issue, and why you might actually not need it. The problem with Null. Tony Orr, the inventor of Null, had this to say. I call it my billion-dollar mistake. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This has led to innumerable errors, vulnerability, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. If you try to use a null value as a non-null value, you'll get an error of some kind. The main problem is that, again, it's pretty much impossible to discern nullable and non-nullable values easily, because everything can be a null. And I believe this just causes more confusion for anyone reading your code, may it be yourself, or a teammate, or an audience member. Rust is a language that I believe is beautifully designed. If you already know about Rust, you definitely saw this coming, and you know what I'll be talking about next. In Rust, there are no surprises, and all bugs are caused by your own stupidity. But most importantly, your code is self-documenting. This means you can look at any given piece of your code and know exactly what errors can arise and where, which variables will be mutated and which won't, and myriad of other things, but most importantly for this video, what can and can't be null. Instead of null, Rust has the option enum. Instead of any value in your program being either null or not null, any value that's an option can either be the sum variant containing the actual value inside, or the none variant. And because option is an enum, this means you are explicitly choosing and allowing some values to be nullable, and are forced to handle the none case every time. The previously shown code snippets can be rewritten in Rust using options like so. And by the way, Rust isn't the first language to have explicit nullability. For example, Haskell has the maybe monad, and Kotlin has the question mark sign. I'm just talking about Rust because I'm most familiar with it, and I believe it employs a lot of good practices in general. Godot is a game engine I honestly really love. In my opinion, it sits right in the middle of hardcore object-oriented programming and fully component-oriented styles. And that makes it really flexible. GDScript, like many other languages, also allows you to null almost everything. Which sucks because few values in your program actually need to be nullable. So, let's introduce a new class. The heavily Rust-inspired option, which denotes that a value can be null. With option, the weapon example from earlier can be rewritten like this. Here, we declare our weapon variable as an option. By doing so, we make it clear that this variable can be a none. In useWeapon, we want to take the weapon only if we use it and it breaks. Taking an option means taking the inner value out of it and leaving none in its place. TakeIf does that, but conditionally. If held weapon is a sum, we want to use it and take it out only if it breaks. And then, if that returns a sum, that means we have a broken weapon, and we just print it out for now. If held weapon is a none, this whole thing just gets skipped. And then down here, we fetch the item's name via a simple map. And the find in array one, like this. Or this, if we want to prevent index out of bound errors when indexing the prices array. And then is a handy method for chaining fallible operations. If index maybe is sum, it calls this function which indexes the prices array, and itself returns an option. Reporting an index out of bounds error here is as easy as adding an otherwise call. At this point though, it would just be better to use the result class that comes with Godot-Optional. More on that later. Here's an example of options in action. In my open world game Craven, I made this component that can influence the world depending on story progress. It works by specifying a condition, which it evaluates at runtime. And based on the result, it fires signals which I can use to, for example, open a door, and keep it open between playthroughs. Here, the variable isSatisfied is an option, because we don't know at first whether the condition should be satisfied or not. If we initialize it as false, we are assuming all conditions aren't satisfied by default, which isn't true. In the story manager singleton, this checkCondition method evaluates an arbitrary condition and returns an option because the parsing or execution of the expression can fail. Back to the component, every time we check the condition, we now must handle the case where something fails. In this case, we assume it to be false, because if something fails, it was clearly my own fault. As you can see, by using options, we are able to encode 3 possible states. One where the expression evaluates to true, one where it evaluates to false, and one where we don't know and are forced to handle this edge case. Now, it's not all just sunshine and rainbows. Godot-Optional also has its own problems. In Rust, the option enum is built into the language as a feature. This means there's a bunch of syntactic sugar and quality of life features that make the usage smoother. For example, Rust has the question mark operator you can place after an option to immediately return from the current function with a none. Or more broadly, patterns like if let or let else are those small things that really make your life easier. Godot doesn't have that. GDScript just isn't designed with things like explicit nullability in mind. So if we try to fill in that hole forcefully, we just end up with a library that feels out of place. In other words, one might say they're fundamentally not compatible. To begin with, it doesn't help that a variable of type option is by itself nullable. How ironic is that? Godot-Optional also comes with additional classes like result, report, or timed variable, but they're not fully fleshed out yet, so I chose not to talk about them much for this video. If you have better ideas for implementations though, please let me know in the comments or by posting an issue on GitHub. I would greatly appreciate it. Nevertheless, I'd be happy if you can find this plugin useful, so if it sounds interesting, please check it out on the Godot asset library or on GitHub. If you like this video, please also consider subscribing for more content like this. I hope you learned something. See you next time.